All right, guys, let's look at the envelope heights journal page on page 286. So let's zoom in and read the directions. It says The Right Stuff, a stationery store, sells a variety of different sized envelopes for businesses and personal correspondence. The heights and lengths of the envelopes are given in the tables below. All measurements are in inches. So you'll see they have one set of data points for the business and one set for the personal correspondence. So the envelope height and length is different depending on what you're going to use the stationery for. Okay, so then it says plot the heights of all the business and personnel envelopes on the line plots below. Okay, so what we know about line plots is you have a title, you have a line on the bottom here that tells you what these points mean, and you have a line plot. Now, when you move from one tick mark to the next, it has to be the same the whole way on your number line. The increments have to be the same. So they left the increments for us, so we're gonna leave them where they are. And remember, if they told us that it's 1/8 of an inch. So these numbers on the bottom represent the height. Because remember, it tells us we're just plotting the heights, and I'm going to put in inches. And then my title is going to be envelope heights, because that is what we are plotting. Oops. Okay, you'll notice those tick marks don't have any value to them, but remember they told us it's 1/8 of an inch. So this would be, let me actually make my pen a different color so you guys will be able to see it, and I'll make it really thin. So this would be 3 1/8, 3 2/8, 3 3/8, and this is 3 4/8, which is the same as 3 1/2, 3 5/8, 3 6/8, 3 7/8, and 4 represents 3 8/8, because that equals a whole. Okay, so let's fill in the rest, and this just helps make easy plotting. So this would be 4 1/8. This is completely optional. You could just leave them blank and just know which one each represents, but I find that this is helpful when you start plotting the ones that are in between the benchmark data points. 6/8, 4 7/8. This would be 5 1/8, 5 2/8, 5 3/8, 5 5/8, 5 6/8, and then 5 7/8. Okay, all done. So now all we have left to do is plot all of the business and the personnel envelope heights. So I'm going to change the color of my pen, and remember I told you I like to cross out as soon as I plot that data point so I don't get confused. So here we have, I'm going to start right here, 3 1/2. So I'm going to find 3 1/2, and I'm going to put an X, and then I'm going to cross it out. 3 5/8 X, and then cross it out. Another 3 5/8, and cross it out. 3 3/4. Okay, so now it says 3 3/4. What would that look like if your denominator was 8? Well, if it was 3 3/4, what would I need to do to make this have an 8? I would have to multiply by 2. So if I multiplied by 2 to the numerator and the denominator, I would get 3 6/8 as my equivalent fraction. So I'm going to plot 3 3/4 as 3 6/8, which is right here. Okay, 3 7/8, another 3 7/8, a 4, a 4 1/8, a 4 1/2, a 4 3/4. So the same thing, 4 3/4 can also be written as 4 6/8 because those are equivalent fractions. A 5 and a 6. Okay, so I'm done with all the all the business envelopes. Now I'm on to the personal ones. The first one is 3 5/8. So 3 5/8, 4 3/8, 4 3/4. So remember 3/4. Actually, I could just put that up here. 3/4 is also equivalent to 6/8. So 4 3/4 would be equivalent to 4 6/8. So that's right here. Okay, we're going to have to do the same thing for 1/4. What is the equivalent fraction with a denominator of 8? So 4 times 2 is 8. So 1 times 2 is 2. So 2/8 is the same as 1/4. So this would be 5 2/8. Okay, now we have 5 1/2. 5 3/4, which is the same as 5 6/8. And then 6. Okay, we finished plotting all of the heights for the business and the personal envelopes. So we're going to use this information on the next page. So I am going to be flipping back and forth, but I'll be zooming in so you guys can see a little bit better. So it says, envelope heights continued. Use the completed line plot on page 286 to answer the questions. Show your work in the space provided. So the first question asks, what is the largest envelope sold? So we're going to go back and look at what our largest data point is. And the largest envelope that they sell is 6 inches. And the smallest they sell is 3 inches, but the smallest one that was sold is 3.5 inches. Okay, so I'm going to fill in what is the largest envelope sold. It was 6 inches. And the smallest envelope height sold was 3.5 inches. Which envelope height is stocked the most by the right stuff? So now we have to go back and look at which one has the most X's. So you can see it clearly, here it has 3, so it's 3 5/8. So 3 5/8 inches envelope was the most popular. What is the difference between the largest and the smallest heights? So let's go back and look. If you subtracted the largest and the smallest heights, you would get 2 1/2 inches. Okay, in the United States, the most popular business envelope is 4 1/8 by 9 1/2. It is called the Standard 10 envelope. How many of the envelopes sold at Right Stuf have a height larger than 4 1/8 inches? So we would go back. We would find 4 1/8, which was right here. So that means everything here is larger. So we're going to count how many were sold. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there was 10 envelopes sold larger than 4 1/8 inches. How many envelopes have a height smaller than that? So we would go back, and any height that's smaller would be over here. So 1, 2, 3, 4, 5, 6, 7, 8. Now notice I did not include 4 1/8 because it's smaller than that. It didn't say equal to or smaller, just smaller. So 8 envelopes are smaller. How much larger is the height of the number 10 envelope than the smallest one sold? So the height is 4 1/8. And then the smallest envelope then the one that was sold is 3.5. But we have to change that half so it has a denominator of 8/4. And I would probably change these both to improper fractions, or change this to I would change them both to an improper fraction. So 4 1/8 would be 33/8 minus 28/8. And you should get 5/8. So the height of the number 10 envelope is 5/8 of an inch larger than the envelope that was sold at the stationery store. So how much smaller is the height than the largest one sold? So if the largest envelope sold was 6 minus the 10, which has a height of 4 1/8, we're going to have to convert these all to fractions. So 6 just means 6 times 1/8. I'm sorry, it would be 8/8 6 times. So if I did that, I would get 42/8 minus 33/8, which should equal 1 7/8 of an inch. Okay, watch the next video for how to do the math boxes.